Hi, I'm Bob DeVries, Director of Product Support and Development here at Nuwool. We put this series of videos together to show you some basic building science concepts. If we've overlooked anything or if there's anything you want to see, please let us know. Thank you. Hope you enjoy. So today we're going to talk about relative humidity. What is meant by relative humidity? Well, humidity is the amount of moisture that the air holds. The amount of moisture that the air holds is relative to the temperature of the air. The warmer the air, the more moisture it can hold. Conversely, the colder the air, the less water it can hold. So on a hot, muggy day in the summer, you say the relative humidity is high. But when you're in the desert and it's so much hotter, it doesn't feel as muggy because the air can hold more moisture. So let's take a look at this. In the center, we have a jar that has half water, half air. That's 50% relative humidity. It's half full, but it's also at 75 degrees. If we take it and bring it over to the desert where it's really hot, and the warmer air is illustrated by the larger container, notice how much more room there is for air than there is water. It's very low in relative humidity. But now let's take that hot desert air and bring it into the cold. Notice how it fills the container completely. At 55 degrees, we have 100% relative humidity. Same amount of water, but different temperatures. This is what is relative about the humidity. Something else to notice that when we go from warmer air to colder air with that same volume of moisture, not only do we get to 100% relative humidity, but you see how it leaked over. That's condensation. So when your windows sweat in the winter, what's happening is the warm, moist air that's in the room gets close to the glass. The glass of the window is much colder. That colder air does not allow the moisture to stay in the air, and it condenses. That's what your windows are doing when they sweat.